In this lesson, we shall look at what happens when light travels through what is called a triangular glass prism. The main source of light on the Earth and the solar system is the sun. The sun emits light in the form of electromagnetic waves that travel to the Earth and even beyond. Light can travel through materials that are transparent, such as air, glass, and water, and each of these materials is called a medium. But when light is traveling between two transparent media, it experiences what is called refraction. Refraction is the bending of light as it travels from one medium to another. For instance, if you look more closely at this image and assume a ray of light is incident on it from the sun, then what you will observe is that as it enters the glass from the air, its direction is slightly bent. Also, as it enters the water from the glass, something similar occurs, and this is what is known as refraction. This is why when you look at a fish in this aquarium, you would be seeing it at this point in the aquarium, but then it is slightly at a different point. But what will happen if that ray of light passes through a triangular glass prism? A triangular glass prism is a transparent block of glass that has 5 sides or faces, with either 2 sides or faces in the shape of a triangle, or has 4 of the sides in the shape of a pyramid. Assuming we place our triangular glass prism on a table and flash a beam of light at it, it is expected that this beam will be refracted. Can you tell me why? Well, it is because refraction is a property of light that makes it bend when it travels between two transparent media. From this image, you can see that the air is transparent and the triangular prism is also transparent. How about we go a bit closer to see what happened to the beam of light as it passed through the prism? To do this, we shall use a ray of light, which is the path of a single photon of light. As you can see, the light incident on the prism at this face was refracted as it reached the boundary of the air and the glass. It then traveled straight in the prism, and as it was about to leave the glass, it experienced another refraction. If we draw 2 lines perpendicular to the faces of the prism, at the point the light entered and left the prism, then we will then have an incident angle here and a refraction angle here, and another angle at the point the light emerged. Let's call this third angle the angle of emergence. So let me ask you another question. If our initial ray was traveling in this direction and it emerged in this other direction, then by what angle was it deviated? This is what is called the angle of deviation. We can find this by simply tracing the initial direction of the ray and tracing back the direction of the emergent ray. These 2 lines will intercept at a point and will make an angle there. This is the angle of deviation. But what will happen to the angle of deviation if the incident angle and the angle of emergence are equal? At this point, we will have the lowest possible value for the angle of deviation, and this is called the minimum deviation. So at the minimum deviation, the incident angle is equal to the emergent angle. If we also look at the peak of this prism, we will see that it also makes an angle. This angle is unique for every triangular glass prism and is called the internal angle of the prism. The refractive index for a prism is given by n equals to sine open bracket a plus d close bracket all over sine a over 2. Note that a here is the internal angle of the prism and d is the angle of deviation. Remember to check out our lesson on the dispersion of light for an amazing phenomenon of light in triangular prisms. Bye for now.